In this lesson, we're going to examine what it means to solve a system of equations, and we're going to do it by the method of graphing. There are other methods, and we'll learn about them down the road, but we're going to stick with graphing because that's what we're familiar with. So a system of equations means two or more equations. We're going to stick with two for now, but we could have three or four or five different equations. And to solve it, we need to locate the point of intersection, the point where they actually meet, where they cross each other. The point of intersection is made up of a point, an x and a y. And it's the one single point where those two lines have the exact same values. In other words, where they're equal to each other. If you think about it as roads, this would be road 1 and road 2, and when you're in the intersection, you happen to be on both roads at the same time. To graph these, to solve them, we have different ways of graphing. Mx plus b is our standard go-to, but we could also make the baby table, or if you really wanted to, the big table. So we have to interpret our question. What methods do I have based on what information I'm given? If we look at the first one, this is in the order mx plus b. The y-intercept is -3, which is right here. That's your y-intercept. And your slope, you can't really see it, but it's 1 over 1. So in other words, we go up 1 and to the right 1. Up 1, right 1. Now in this case, I'm going to keep adding more points. Up 1, right 1, up 1, right 1, up 1, right 1, to make sure my line stays straight. It's really important to have a straight line because I want to figure out where the two lines meet. If my lines are crooked, maybe they don't meet, or maybe I have the wrong point. If we try the next one, it's not quite in the right order, but it's very easy for me to change it to the right order. Notice that my signs didn't change. I just changed the order of them. In this case, my y-intercept is +1. It's right here. And my slope is -1 over 1, or in other words, I have to go down because it's negative, and right. So down 1, right 1. Down 1, right 1, down 1, right 1. And if you notice, I just cross the other line. It's kind of important, kind of helpful, because that is my point of intersection right here. That's the second reason I put a bunch of dots on it, so I can maybe find the right dot without having to worry about having straight lines or crooked lines. My solution to this question is that point, that POI as I like to call it. That point is located at 2 and -1. And I've solved that system. Okay, so let's try the next one. Alright, first equation. It's not really in the right order, but I can quickly fix that by switching some things around. If I bring the y to the right side and the -2 to the left side, I get x plus 2 equals y. Or in other words, y equals x plus 2. That didn't take much thinking in terms of rearranging. It was pretty quick to do. So I'd say it's worthwhile to do that. Our y-intercept is 2, and our slope was 1, 1. So up 1, right 1, up 1, right 1, up 1, right 1. And there's my graph. The second one is already in the right order. Its y-intercept is 0, and its slope is up 2, right 1. So up 2, right 1, up 2, right 1. Ooh, look, I found the point of intersection. It's right there. Ooh, it's a little crooked. Okay. The fact that I made my dots tells me I know what the POI is already. The POI is right here. Its answer is 2 to the right and up 1, 2, 3, 4. That's my point of intersection. Okay, so I'm going to give you a couple more. I want you to try these. They aren't necessarily in the right order sometimes, or other things going on. Let's see what we can do with them. Okay, let's try the first one. 4x plus 3y is 12. That would take some rearranging. So I'm going to use the baby table method. 0 and 0. If x is 0, really I get 3y is 12, so y is 4. 0, 4, right there. If y is 0, I'll get just x is 3. Oh, that was quick. There's my first graph. The second one. Again, it's not really in the right order, and there's a number in front of the y, so the baby table method might be pretty quick. If x is 0, I get -2y is 3. Ooh, I'm going to get decimals this time. 3 over -2, which is -1.5. So, -1.5. 0 and back 1.5. Oops, sorry. 1.5 is on the y-axis. Make sure it's in the right spot. Okay to get decimals. Nothing wrong with decimals. Oh, you know what? I just combined two different questions into one here. Sorry, guys. I'll have to fix this. Let's go back to the first line. My fault. Fix this. I think I did the first one right. X is 0. We got 3y is 12. Yeah. And y is 4. But I looked at the second line. My fault. Totally wrong. Okay. We get 4x is 12. So x is 3. Yeah. 3 and 0. I had that right. And 0 and 4. I had that right. Okay. Back to our table making. I want to figure out this one. So if y is 0, and I'm using the second equation, I get x is just 3. That's what I was looking at before. So I get 3, 0, which is kind of nice, right? If you already look at your table, you know our POI is right there at 3, 0. In fact, I didn't need the graph this time because in my table, I figured out 3, 0 and 3, 0 was the same point. So I wouldn't even ask you to make the graph if your table gives you the numbers. Okay, let's try one more. Again, messy order. So let's do that table idea. Make sure we do the right table this time. X, 0 and 0. If x is 0, I get 2y is 4, so y must be 2. If y is 0, I get x is 4. Okay, try the next one. X, y. If x is 0, I'll get 4y is 8, so y is 2. And if y is 0, I'll get 2x is 8, so x is 4. And whoa, if I take a look at my tables, what do I notice? I notice that I have 0, 2 and 4, 0 for the first line and the second line. In other words, these lines are on top of each other. So what do I say about a point of intersection in this case? I have to say something like, they're the same line. There's an infinite number of point of intersections. And that can happen sometimes. You take a look at your equations and you notice that, oh, hey, those are the same equations, just different versions of each other. And there are actually 3 situations we can have when we talk about systems of equations. We could have where they meet at one spot, like we've been doing. There could be an infinite number of points that are lying on top of each other. And sometimes they may not even meet. Maybe they're parallel to each other. But we'll leave that lesson for another day. Okay. Sometimes you want to check to see if you're doing this right. The way to check to see if you're doing it right goes back to how we learned to solve equations algebraically. We take the point of intersection and we put it into our equations. If it makes the equation work, it's the point. If it doesn't, it's not. So if we look at the first example here, I have the point 4, 2. And I want to know if it's the solution or not. Well, if I take that point and I substitute it in for the x's and y's, I'll get, we'll write out here, x plus y is supposed to be 6. Well, if x is 4 and y is 2, like it says in the question, then sure enough, 6 is 6. It seems like it's working. But I have to make it work in both equations. So if I take the second equation and I use the same values, x is 4 and y is 2, and I do the math on the left-hand side here, I get 6 is 6, and I notice that it worked in both. So we could say that yes, this is the solution. Okay? But it must work in both. If it doesn't work in one, you've proven it's not on that line, so it can't be the solution. Let's try that point in the second example. I have 3x minus 2y is 8. I think x should be 4 and y should be 2. That's what it gave me in the question. We're using the same point, okay? So we'll get 12 minus 4. Yeah, 8 is definitely 8. So far, so good. It seems to work. If I try the next one, however, and I put in 4 and 2 for x and y, I get 2 equals negative 2. Well, those aren't equal. They're not equal. So this is not the solution. It's on the first line. Sure, it worked in this one, but it's not on the second line. So it's just some random point. Okay, so you can check your math. And I'm not going to make you show the check every time, but mentally, why wouldn't you try to show the check, try it to see if you got the right answer or not? Last one, word problem. Go back to grade 9 math for a second here. The Perfect Paving Company charges $10 per square foot to install paving stones, as well as a $40 delivery fee. Interlock Star, which is a second company, charges $13 per square foot, but has a $20 delivery fee. This kind of question should sound familiar. These are the kind of questions we did in grade 9. I want to start off by writing an equation for each company. But we know when you write equations, especially in word problems, we need to define our variables. So we need some let statements. What does X stand for and what does Y stand for? In this case, X should stand for the square footage. How many square feet of stone do you have? And the more square foot you have, the more your costs will be. Okay. Square footage is our independent variable. You get to decide how big you want your paving and how much paving you need to do. But depending on how much you pick, your costs will change accordingly. So we should have two equations. Our perfect paving company should have the cost, the Y, and it should be $40 for delivery plus $10 for every square footage. Okay. The second company, Interlockstar, should be the same idea. It's going to cost you $20 to deliver plus $13 for every square footage. Okay. I want to graph my equations. So let's graph the first one. Do this one in red. This one starts at $40. And it's going to go up $10 for every square feet. So it's going to go at 50, then 60, then 70, then 80, then 90, then 100. Okay. The second one starts at $20. It's your initial value, your y-intercept, if you will. And it goes up $13. Now, that's a little bit harder to judge. So rather than trying to go up 13 over 1 every time and trying to estimate, that's kind of hard to estimate, right? Something like that. I'm going to pick a point down the line that I can actually calculate. That will make my life a little bit easier. So let's try, what's a nice number here? Let's try 5 square feet. 20 plus 13 times 5. That'll give me 20 plus 65 is $85. So for 5 square feet, it's going to cost me 85. So that's halfway in between right here. Now, why did I pick that number? I picked that number because I know 5 times 13 is a reasonably nice number. It's halfway between 80 and 90. And if I have 2 points, I can graph a straight line. Okay, now I'm hoping you guys can use your rulers to make your straight lines. I don't have a ruler on mine, but you guys should. Make your life a little bit easier. So, here's our graph. Let's do part C. Which company would you recommend? Well, we want to recommend whichever one's cheaper, right? So we usually answer these questions in the style, it depends. It depends on the number of square feet of paving. Okay. Initially, starting, Interlockstar is cheaper. Oh, you know what? I made my graph wrong. What was I doing there? I should start at 20. I started at 40. Sorry, guys. We'll fix that. That's completely off. 20 is down here. And we said 5 was 85 right there. There's my graph. Much better. Okay, it depends. Which one's cheaper? Interlockstar started at 20, right? It was the initial value, and this was the initial value. Interlockstar is cheaper to start up until we get to the POI, right about there, until about 6 square feet. So for 6 square feet or less, Interlockstar is cheaper. After 6 square feet, whatever the other company was, Perfect Paving, something like that? Yep, Perfect Paving. Perfect Paving Company is cheaper. Okay. But I'm hoping you also notice that this is the kind of situation where it's getting a little bit hard to tell. The idea of graphing a solution is good as long as they meet in a nice spot. Now, in this word problem here, this nice spot, the supposed nice spot, 6 feet, I don't know how accurate that really is. that dot doesn't fall right on a grid line. In other words, it doesn't fall right in the corner of something like right here. I can say, oh, that's 6 and 40. That's easy to tell. It's kind of in between. And that's kind of why, even though graphing works, it's not bad, it takes a little bit of time. It's not really the best method because we can't be positive on our answer unless it falls on a nice even grid line. So we are going to learn some methods down the road where we can do that without having to graph. We can solve this algebraically. Okay, some questions you should try. These ones are nice ones. They're all going to fall in nice spots. Yeah, I believe there's one no word problem in there, but other than that, everything should be pretty straightforward. So give them a try. If you're stuck with some stuff, come see me. Remember, the idea of a POI is you need to have a point. Make sure you have an X and a Y. That's the solution.